But what we're covering today is the last two types of special factors that we covered last semester. And the first one is our sum and difference of perfect cubes. Sum and difference of perfect cubes. Now, when we had this here, our set formula a cubed plus b cubed, or a cubed minus b cubed, if we have two numbers, a and b, that are perfect cubes, a number that can be multiplied by itself 3 times, and they're either added or subtracted, we can factor it. And there's a special way that we can do it. So we had a little one and a big one. And our first main step when doing this is that we would cubed root a and b. So we take the cubed root of a cubed and take the cubed root of b cubed. And part of this was to see, can I take the cubed root of both of those terms? Because if I can, then we can have a sum or difference of perfect cubes. But it also helped us when plugging it in, because now we know these terms and we can kind of line it up. Now, when we went through this the first time, I told a funny little story kind of with dating and relating it to figuring out what the signs were. And what we figured out is, well, the signs are going to be the same, opposite, always end on a positive note. So the sum of two cubes would be plus, minus, plus. The difference of two cubes would be minus, plus, plus. So our two sets of signs would follow this pattern. Same, opposite, always end on a positive note. Same, opposite, always end on a positive note. Now, when we plugged in a and b, it would be a, b, b, because it's just them to the first power in the smaller box. In the bigger one, we would have a squared, a, no a, b, b squared, a squared, ab, b squared. Because the term with a, that first spot is going squared, first, 0, and b is going 0, first, squared. So they're kind of going this opposite. One's going down, the other's going up. And so that's what we have here. And this is kind of the set formulas for these. So if you are watching the video, it'd probably be good to write this down. I already wrote it down on the board for y'all in here so that you can have it and look at it. Because unfortunately, I'm going to have to erase this because I don't quite have space. So when we look at this here, we want to see, is this a sum or difference of perfect cubes? Now, we can kind of check it to make sure and see if we can take the cubed root of x to the third and see if we can take the cubed root of 125. Well, the cubed root of x to the third is just x, because whenever the root and the exponent are the same, they simplify out completely. They cancel out. Now, the cubed root of 125 would be 5. 5 times 5 is 25, and 25 times 5 is 125. So this one here, both of these here are perfect cubes. So we can factor this using our sum or difference of perfect cubes. Now the signs, we know what they're going to be because it's the same, opposite, always end on a positive note. So since this started out as a sum of perfect cubes, so our first sign would be plus because it's the same, and then opposite, so minus, and always end on a same, opposite, always end on a positive note. So plus, minus, plus. Now our first term in this case is going to be x, or a. Bless you. Is going to be x. So if we fill this in for the first term, well, we would have just x squared, and then x. And then the last one in the bigger one would be x to the 0, which is just 1. Anything to the 0 power is 1, so we don't really write it in. Now our b term, or the second term, is 5. So this first one would be 5. Now, again, in this spot with x squared, well, we'd have 5 to the 0. Well, 5 to the 0 is 1, so we really don't write it in. The middle one would be 5 to the first, and then we would have 5 squared. Any questions on anything we've done thus far to get to here? So it's the same one from yesterday. You were here yesterday? Okay. Right here. I think we might be one page the other direction. Now the last thing we need to do is just simplify it. So it'd be x plus 5 times, well, this would just be x squared minus, well, 5 times x is 5x plus 5 squared would be 25. So that's it. So kind of like with our difference of squares, difference of perfect squares, it's kind of just filling it into the formula and it works out nicely. That's about what we're going to be doing with this here. So x cubed minus 64. Now in some of these here, it might be helpful or useful to see if there's a greatest common factor, because there can be a greatest common factor that we could factor out. But here there's not. So we'll see, can we take the cubed root of x to the third? And can we take the cubed root of 64? Well, the cubed root of x to the third is going to be x. It's kind of nice. When the exponent and the root match up, it's kind of nice because they just cancel out. They simplify out. Now, the cubed root of 64 is 4 times 4 would give us 16, and 16 times 4 is 64. So it does work. We do have a sum or difference of perfect cubes. So when our factors that we're going to put down, we'll have 2 sets of parentheses. One's going to have 3 spaces. The other is going to have 5. Now we can look at the signs. And again, the signs are going to be the same. Opposite always end on a positive note. So that'd be the same. We would have negative, positive, positive. Same. Opposite always end on a positive note. So negative, positive, positive. Now we're going to kind of fill in. So I'm going to fill in with the first term. So term A, or the A term in this case, would be just x. So here we would have x. This here would be x squared. Then we'd have x to the first. And lastly, we would have x to the 0, which is just 1. So we don't really write that in. And that brings us to our b term, the other term, which in this case is 4. So we would have 4, 4 to the 0, 4 to the first, and then 4 to the second, 4 squared. Any questions on any of this thus far? Well, now we can really just simplify, because we'd have x minus 4. Then here we'd have x squared plus 4 times x would be 4x plus 4 squared would give us 16. And that's it. That's all we need to do with this here. Any questions on anything we've done so far? Not too bad. Hopefully this is getting easier as we do them. The more that we do, the more that you do. Pin down. Okay. Let's look at this one here. 27a cubed plus 64. Why not? Let's change it up a little bit. Let's say b cubed. So we're going to add that in. I'm going to make that little tweak to this problem here. And we'll say 64b cubed. Because I just want to show you one that has two variables in it. And it's not going to change it too much. It's just we're going to have b terms. That's the only real difference. So when we look at this here, again, we can see if we can take the cubed root of 27a cubed. And see if we can take the cubed root of 64b cubed. Well, the cubed root of 27 is 3. 3 cubed is 27. And the cubed root of a to the third is a. Because when the root and the exponent match, they simplify out. Now, the cubed root of 64, we just saw that a minute ago, is 4. And the cubed root of b to the third is b. So we can take the cubed root of these two here. These are perfect cubes. So that means we can factor it. 3, 1, 2, 3, 4, 5. So our signs are what? Positive, positive, negative, positive. Positive, negative, and positive. Okay. Then we can move on to our terms. So 3a will go in our first spot. It'll be our a term, quote unquote a term. Because we'd have 3a, and then here we would have what? 3a squared, 3a to the first power, and then 3a to the 0. So it would just be 3a, and then we wouldn't put anything in the last spot, because anything to the 0 power is 1. Any questions before we move on to the other term? So our other term is 4b. So in the first spot over here, we'd have just 4b. We wouldn't have anything with 3a squared. In the middle, it would just be 4b to the first. Then over here, we would have 4b squared. Put that inside parentheses. Well, all that leaves us with is simplifying this. Because once we got to this here, we just need to simplify it down. The 3a plus 4b won't simplify any further than what it is. Now 3a squared, we have to square both terms. So 3 squared would be 9, and then we would have a squared. Because we have to square both the 3 and the a. We have to square them both. Now the middle terms, we're going to have to multiply them together, 3a times 4b. Well, 3 times 4 would give us 12, and then we would just have a b plus 4b squared. We square both of them, so 4 squared would give us, and then we would have b. And that's it. So even though I added that b cubed in there, the process that we went through and the process that we did to solve or factor this didn't really change, did it? No, it stayed the same. Any other questions on this? Yeah. All right. Let's do this last one here, and then we'll move on to grouping, because I have a feeling y'all have pretty much gotten the hang of this, yes? Okay. So let's see here. Can we take the cubed root of 192? Cubed root of 192. So on the graphing calculator, if you want to use or take a cubed root, you can do math, and you can scroll down. There should be one that's a cubed root. And so we can take the cubed root of 192. Well, that doesn't work, does it? Okay. And 81 doesn't work. Well, wait a minute. Is there a greatest common factor between these two here? So let's see here. If I factor a 9 out, 192 divided by 9 would be what? Okay. Well, I think 9, or kind of that number's on the right path. Try 3. Let's see what 3 does. So that does work, and I know 81 is divisible by 9. 81 divided by 9 would be? Not 9, sorry, 27. Because 81 is 9 times 9. But it's also 81 divided by 3. Because 8 goes into 3 2 times. Which leaves us with 21, which would be 7. So it does go into it 27 times. I misspoke. Yeah. It goes into it. We can factor out the 3. So now let's relook at this and see if I can take the cubed root of 64x cubed and see if I can take the cubed root of 27y cubed. Well, we know 64x cubed is going to be 4x. Well, we already saw that one. Yes? At 27, okay, well, we saw this one here already. It's going to be 3y. So we can these are perfect cubes. It just worked out that there was a greatest common factor between them that we had to pull out first to be able to get them to perfect cubes. So, 3 spots, 5. And our signs would be the same, opposite, always end on a positive note. So minus, plus, plus, negative, positive, positive. Now we can move on to our first term, so 4x. So we would have 4x, wouldn't put anything there, then we would have 4x squared, 4x to the first, and then lastly we would have 4x to the 0, which is just a 1, but we don't write it in. And then we can move on to the other term, which would be our 3y. Well, we'd have 3y to the 0, 3y to the first, and then 3y squared. Yeah, this is all really gearing up towards us factoring in our rational functions. And once we simplify this here, and simplify the squares and multiplication, we get this. Any other questions on this here? Okay. we're going to move on to the last type of factoring that we're going to look at. And that is grouping. Because this last type that we're looking at is called factoring by grouping. And you can really consider this also kind of greatest common factor twice or three times. That's going to work out 3 times. And that's all we're doing is we're really using greatest common factor. And we're breaking it up and grouping them together. So what we can do is we can look at, say, the first 2 terms and the second set of 2 terms. So first and second term, third and fourth term together. And seeing, is there a greatest common factor between them? And now, I'm going to preface this also. You normally only use grouping if we have 4 or more terms. So when I look at this here, is there a greatest common factor between 2p to the third and 5p squared? P what? P squared is in common with both of them, yes? Because 2 and 5 don't have a common factor, but p cubed and p squared do have p squared in common. There's 2 of them in common. So we can factor that out. So if I factor 2 p's out of p to the third, I'm left with 2p. Because I took 2 away, so I'm only left with 1. Plus 5p squared, well, I'm just left with 5 because all of the p values factored out, yes? That's going to work out. We're going to have plus. When I look at these 2 here, 6p and 15. Yes. Is there a greatest common factor between 6p and 15? Mm-hmm. 3. So we can factor that out. Because if I divide 6p by 3, I'm left with plus. Mm-hmm. So we factored that 3 out. So any questions on this here so far? That's what we want. That's what we want to have happen. Because what our goal is for this here and this here to be the exact same. That's why I call it greatest common factor twice or 3 times. Is I factored something out of both of these here. Okay. And once I did that, well, now we have something in common with these 2 things added together, yes? So I can do greatest common factor again. But what I'm factoring out this time is going to be our 2p plus 5. I'm going to factor that whole term out of both. Because when I do that, if I factor 2p out of this one, I'm left with p squared. Plus, when I factor it out of the second term, I'm just left with yeah, so we're just pulling this out of both of them, which leaves us with our p squared plus 3. And that's it. So we really use that greatest common factor twice. Mm-hmm. And this here is it. Now we can also make sure and look at both of them and see would they factor. Well, p squared plus 3 does have a power greater than 1. We have p squared. But p squared plus 3 isn't something we can factor. It's not a difference of perfect squares. So we're done. This is it. Questions on this here? Yep. So let's look at these here. So I'm going to group the first 2 together and the second 2 together. So when I look at 3n cubed minus 4n squared, well, 3 and 4 don't have a greatest common factor. Not just n, but we have n squared. So when I factor n squared out of 3n cubed, I'm left with 3n minus 4, because when we factor n squared out of 4n squared, we're just left with minus 4. Now, what we can also do is we can look at what's in here, because we want what's inside the parentheses to be the same. So whatever we factor out of the next one, we want what's left over to be 3n minus 4. Yes? So what do I need to factor out of 9n to get to 3n? 3. Yes? What do I need to factor out of 12 to get to 4? 3. Yes? Are the signs lining up? Is 9n and 3n both positive? Is negative 12 and negative 4 both have the same sign? Yes? Okay. So that means we're just going to factor out plus 3. If it was negative 9n and positive 12, well, we need to change the sign, yes? So how can I change the sign? By factoring out a negative. Because if it's negative and I factor out the negative, it becomes, if it's positive and I factor a negative out, it becomes, Yep. And so what we have left over inside is 3n minus 4. Okay. So now we have it set up so that there is a set of parentheses that's in common with both. And so we can factor this out. So we can factor out 3n minus 4. And when we do that, what's left over? N squared plus 3. Any questions on this here? Right, because 3n and 1, there's nothing that goes into it. Yes? So let's look at the first two. What's the greatest common factor between 12n cubed and 4n squared? And then what? N 4n squared, yes? So if I factor 4n squared out of 12n squared, well, 12 divided by 4 will give me n plus. Since 4n squared, we factor out 4n squared, it factors out completely. We just have plus 1, yes? I mean, I could put parentheses around it because we can see that when we factored out 4n squared, we're left with 3n plus 1. Well, the other two terms are already 3n plus 1, yes? So we don't have to do anything to it because, well, these two already match. So when we factor this out, what's left over? Well, and then what? Any questions on any of this here? I think that brings us to the last one. Yes? 224az plus 56ac minus 84yz minus 21yc. Yeah, so we can factor out an a. So over here, so I wouldn't say z because we do have z in both of the first and here and here, and we have c here and here. So we're not going to mess with z or c. So a and y, I can say, would both come out. But now it's coming down to the numbers. What is the greatest common factor between these two? So 2, 24, and 56, those are kind of really big numbers. It's hard to see what a greatest common factor between them is. Would y'all agree with that? So we have that. So let's put that on the back burner. Let's look at these two here. Because 84 and 21 might be a little bit easier to look at. Because I do know 3 will go into both of them, yes? Well, 21 can go into 84. 4 times, yes? So the greatest common factor, the biggest number I can take out of here is 21, yes? And we would also have y. Now, what else do we notice about these two here? They're both what? Negative, yes? Are the other two numbers 22, 24, and 56 negative? No. So probably to keep them lined up, I'll need to pull that negative out with it. To keep everything inside the parentheses, what's left over positive, we'll pull that negative out. Now, when we do this, factor negative 21 out of 84, we're left with 4. The negative and negative factor out. We factor out the negative. 84 divided by 21 would be 4. And we would have z. We can do the same thing with negative 21 yc. Well, if I factor out negative 21, I'm left with plus c. Yes? Okay. Now this is kind of why we did this first, because it's a little bit easier to see with 21 and 84. Would you all agree with that? So it'd be 56. Because when we look at this here, I have just c, yes? So after we factor something out, this 56ac should be just left as c. So we can look and see, does 224 divide by 56? And it works out that it is. It divides 224 divided by 56 is 4. So our greatest common factor for the first one is going to be 56a. So doing the second pair actually helped us figure out what the first pair was going to be. And when we factor this out, we're going to left with 4z plus c. Any questions on this here? Now we can do the last set of greatest common factor, which would be 4z plus c, factored out of both, which would leave us with what? And then what? Mm-hmm. And those would be our sets of factors. Any other questions on any of this here? Okay.